Hello, friends. Over here in this class, we're going to talk about analytical geometry concept 3, wherein we are going to cover how to find a, a series of points or an equation of a line which is perpendicular to another line. So the problem is something like this. Like, let's say that, we have a line that we have taken and the line is stretching over here. So I'm going to draw the line first, and it's really given over here. Now the question is that this line is indicated by x1, y1, x2, y2, and we have covered what we call the midpoint in one of the previous videos, right? So you remember that the midpoint is given by the point M, which is really x1 plus x2 by 2 and y1 plus y2 by 2, right? The problem that we are trying to solve over here, the question is that is one point, but are there other points which are equidistant from x1, y1 and x2, y2? And the answer is yes. So what will be those points? So for example, it is M is on the line, but let's say that if there is another point over here above or below, right, that you draw a perpendicular, then each of the points on this perpendicular, they're really equidistant, right, from both these ends. So the question is, what is the equation of this perpendicular line? So let's put some indication as to which one it is. So the line AB is, for example, the one with the coordinates. What we need to do is we need to find the equation for the line CD, right? That is what we need to find. So before that, one of the concepts that is very important to remember, and I will prove it in a separate video, but it's important to remember that slope of any two lines which are perpendicular to each other, it's -1. In other words, let's say that the slope of AB is M1, right? And slope of CD is M2. Then again, we will prove it in a separate class, but for now, just know that M1 times M2 is equal to -1. And that formula is going to help us, okay? So we're going to find the formula, the equation for line CD. Now, the equation of line CD is always the standard form of equation is y equals to mx plus c, where m is a slope and c is the y-intercept, right? And that is what if we can find m and c, then we are in business. We have found the equation, right? In order to find the equation, I gave you the hint that slope of CD will be product of, if I have to find the slope of CD, which is M2, it is nothing but -1 of M1. So now you're wondering, what is M1? So M1 is the slope of AB. And how do you find the slope of AB? That is y2 minus y1 by x2 minus x1. So that is really M1. And when we make a negative of that and a reciprocal, so then in other words, it becomes x1 minus x2 by y2 minus y1, right? So if you have not, means it's just the reciprocal, which means that you flip it around and it's a negative, so it becomes x1 minus x2, y2 minus y1, okay? So we now know the slope. We now know the slope, but we still don't know what is C, right? What is C? We don't know. So how do we find C then? In order to find the C, you have to solve, like, you know that what is M over here, but what is X and Y? The hint over here is that this line CD also has the midpoint M. And you know that M is x1 plus x2 by 2 and y1 plus y2 by 2. So in other words, for y, you represent it by y1 plus y2 by 2 is equal to the slope, right? Which is, we have found it over here. So it is x1 minus x2 and y2 minus y1 times x. And what is x we did? So x we did was nothing but x1 plus x2 divided by 2, right? It's becoming a little unclear as I'm scribbling and writing over, but if if I were to write it in a clean place, it will be y1 plus y2 by 2, right? That's what it is. And it is y1 minus y2 by x2 minus x1. Sorry, it is this slope, so that's x1 minus x2, and it is y2 minus y1, right? So it is this slope. So x1 minus x2 divided by y2 minus y1, right? And then you multiply it by x, which is x1 plus x2 by 2. So that gives you mx and then c, right? So now that you got these points in real world, so you'll be able to find out what is the value of c. And then all you need to do is plug that back into that equation, y equals to mx plus c, and you get the answer. So that's how it's being done. I showed you what the proof is, but that is how exactly you can solve any of the problems related to finding any of the lines which is perpendicular to another line passing through two different points, and which is perpendicular and it is equidistant. Remember, this formula cannot be applied as is if it was just another perpendicular line. This one works well when it is a perpendicular line and it is passing through the midpoint of that other line. Okay. Hope you had some fun and understood how it's being done. Uh, if you have any questions, write back to excelsteam.org and we'll be happy to help you. Bye for now.